Hello students, welcome to Saurav Sir's classes. We are solving the IIT JAM Statistics 2013 question paper, and the first problem that we have today is let A be a 3x3 real matrix with eigenvalues 1, 2 and 3, and let B equal to A inverse plus A square. Then the trace of the matrix B is equal to what? If A is equal to some matrix, then we have PAP inverse equal to 1, 2, 3, as it can be diagonalized. Now B is equal to A inverse plus A square. Now PB P inverse is equal to PA inverse P inverse plus PA square P inverse. Now PA inverse P inverse is equal to P inverse I beg your pardon, PAP inverse whole inverse, because the P inverse gets in the beginning, it becomes P, A has A inverse and we get P inverse. So this is fine, and this is just equal to 1/2 and 1/3. PA square P inverse is equal to PAP inverse whole square, which is equal to 149. So we have trace equal to 1 plus 1 plus 4 plus 9 plus half plus 1/3, which is equal to 95/6. So B is the correct answer, and we move on now to the next question. Let f from R to R be defined by fx equal to x square if x is rational, alpha x plus b if x is irrational, where alpha and beta are real constants. If f is differentiable at x equal to 1, then the value of 3 alpha plus b is equal to what? So firstly, f is differentiable at 1, so f has to be continuous at 1. If we take xn belong to q, xn going to 1, and yn belong to r minus q, yn going to 1, limit n goes to infinity, f of xn is equal to 1, and limit n goes to infinity, f of yn is equal to alpha plus beta. Therefore we have alpha plus beta is equal to 1. Now it is differentiable at x equal to 1, so limit as h goes to 0, f of h minus f of 0, which is 0, by h exists. Now take hn belongs to r minus q such that hn goes to 0, then limit hn goes to 0, f of hn is just alpha hn. So this is f of 1 plus h minus f of 1, I messed up here, and this is h. So alpha of hn plus 1 minus 1 by hn plus beta. So this gives us alpha plus beta minus 1 by hn plus alpha as limit hn goes to 0. So again from here alpha plus beta has to be equal to 1, because as hn goes to 0 the numerator has to go to 0 for the limit to exist. So we do not actually get anything new. If we take hn belongs to q, we find limit h goes to 0 f of 1 plus hn minus 1 by hn equal to 1 plus hn square minus 2hn plus 2hn minus 1 by hn as hn goes to 0. Now the 1 and 1 gets cancelled out and hn cancels the hn in the numerator, and we have limit as hn goes to 0 hn plus 2. So this we know has to be equal to 0. But this here limit hn goes to 0 hn plus 2 is equal to 2. So now we know that the derivative f prime of 1 is equal to 2 and this is equal to 0. So alpha has to be equal to 2 and beta has to be equal to minus 1. So 3 alpha plus beta is 6 minus 1, which is 5. We will move on to the next question now. Let an be a sequence of real numbers such that mod an is less than equal to root n, then limit n goes to infinity e to the power an by n plus root n sine root over 2 by n is equal to what? Another complicated expression. We have to find the limit. So how do we do it? Sine root over 2 by n by root over 2 by n goes to 1 as n goes to infinity as limit x goes to 0 sine x by x equal to 1, the general formula. So this thing here is equal to sine root over 2 by n by root over 2 by n times root 2 plus e to the power an by n, and we already know this goes to root 2 as n goes to infinity. So what we are left with is this. Now e to the power an by n is less than equal to e to the power 1 by root n, greater than equal to e to the power minus 1 by root n. So this goes to 0 and this goes to 0, implies this goes to 0 by sandwich theorem or sandwich lemma, and we get that this term goes to 0. So this entire limit is equal to root 2. We will move on to the next question. Consider the linear system x plus y plus 2z equal to alpha, x plus 4y plus z equal to 4, 3y minus z equal to gamma. In the unknowns x, y and z, if the above system always has a solution, then the value of alpha plus gamma is equal to what? Now what is the matrix? The matrix is 1 1 2 1 4 1 0 1 minus 1. determinant of A is equal to 1 times minus 4 minus 1 plus 1 times plus 1 plus 2 times plus 1, which is equal to minus 2. Now since determinant is not equal to 0, rank of the matrix is equal to 3. If we name these equations 1, 2 and 3, 2 minus 1 gives us 3y minus z equal to 4 minus alpha, and we have 3y minus z equal to gamma. Therefore 4 minus alpha is equal to gamma, and alpha plus gamma is equal to 4. So alpha plus gamma is always equal to 4, and our problem is solved. If you have any queries, please post in the comment section and press the like button if you like the video. Please subscribe to our channel for more such interesting videos. Thank you.